Hey everyone, I'm doing a video on standard form quadratics. This is different than vertex form, which you've already seen. So first of all, let's just start out with what's the form called standard form. Okay, so the first equation that you see on here, y equals ax squared plus bx plus c, is in standard form. This is also what we call the polynomial form. So a specific equation for this parabola that follows this standard form pattern is 1/2 x squared minus 4x minus 3. All right, so I'm sure the first thing you guys are thinking about is, okay, well, what is that a, what is b, what is c, and all that stuff. Okay, so those are coefficients. They're just placeholders, all right? So I've kind of mapped it out for you. A is the number in front of the x squared term. Okay, so in this case, on a specific equation, it's 1/2. Okay, B is the number in front of the x term, just x to the 1. That number is minus 4. And then C is always some sort of a number. It's not in front of any variable or anything. Okay, and C corresponds to minus 3. So there you have it, A, B, and C, and that's how you identify them. Now, the three things that I need you to know about this standard form and parabolas is, one, how to find the vertex, which is a coordinate pair, x, y, so it's a point on the graph. Two, how to find something called the axis of symmetry. And three, how to find the y-intercept from the specific standard form equation. It's a different process than how you had to find it when you were using vertex form. All right, so we're going to get to that in a second. So just take a pause and look at how I matched up A, B, and C with their corresponding numbers. All right, so now let's find the vertex. Okay, so the first thing you need to know is the vertex is a coordinate pair. Okay, so I'm going to show you. I'm going to write it first as x comma y, and then we're going to find first the x, and then we can find the y. So there's a formula to find the x value of our vertex. So that's going to be equal to, okay, and this is where the b's and a's and things like that come into place. It's minus b over 2 times a. All right, that's the formula. You'd find the x by doing the math with minus b over 2a. So it's important to know how to find b, a, c, all those things. Okay, and I laid it out for you. So b is minus 4. So this would be minus of minus 4. We're just filling everything in and substituting and evaluating. Over 2 times a. A is 1/2. Okay? So I'm going to put that in parentheses like that. All right. So minus of a minus 4 is a plus 4. 2 times 1/2 is just 1. So our x value is going to be 4 over 1, or 4. So I'm going to write that over here. I'm going to say x is 4. Okay, and now I have to find y. All right, so y is found, well, it's found using this equation right here. Okay, I'm going to just circle it or put an ellipse around it. Okay, in order to find y, I have to plug in the value that I got for x into this equation, and then it'll give me y. So y is going to be equal to 1/2, okay, of 4 squared minus 4 times 4, okay, minus 3. All right, so if we do the math, we end up with 4 squared. We always do the exponents first, follow PEMDAS. 4 squared is 16. Half of 16 is 8. So 8. And then minus 4 times 4 is 16, so that's 16, and then minus 3. So, wow, I didn't really think this thing through too well, but it's going to end up being 8 minus 16 is minus 8, and then minus 3 is minus 11. So, so my vertex is going to be at 4 comma minus 11. All right, so um, the reason I said I didn't think it through too much is because this thing only goes down to about 10. So I'm going to go over to 4, and then I'm going to come down and figure out that like right about here would be minus 11. Okay? So 4 minus 11, that's my vertex. So that's the first thing that you need to be able to figure out is how to find the vertex. And again, the process is find x first by doing minus b over 2a, and you get your number. And then you take that number and you put it back into the equation, and you do the math in order to find the y. All right, so take a moment to digest that, write it down in your notes, because you are going to need this in order to do your quiz whenever it is I give that quiz. All right, now we're going to talk about the axis of symmetry. Axis of symmetry. So what is an axis of symmetry? Okay. Well, we know what an axis is. We know what an x-axis is, and we know what a y-axis is. And they're lines, right? They're lines that go on infinitely. X and y are special in that they form the coordinate grid, but an axis of symmetry is also a line. All of the parabolas that we're working with are vertical, meaning they open up or down. So consequently, our axis of symmetry will also be a vertical line. All right, so I'm going to write over here A, that's an A, O, S, that stands for axis of symmetry. Okay, and since it's a vertical line, and all vertical lines have the form x equals some number, okay, our axis of symmetry will also be x equals some number. Okay, in this case, we previously calculated the vertex to be at, and I'm going to write it over here, vertex v was at 4 comma minus 11. Okay, and that's our x and y value. So since, all right, so it's a vertical line, and here's what's special about it. It's a vertical line that goes right through the vertex, okay? So in this case, our vertex has an x value of 4. So our axis of symmetry will be a line that goes right down the middle of the parabola, which means that it also goes right through the vertex, okay? So what I'm going to do is come over here, and I'm going to get a little line tool. Okay, and I'm going to make this a dashed line, okay? And wherever x equals 4, so I'm just going to start way up here, okay? I'm going to, oops, that didn't work out too good. Maybe what I'll do is I'll just undo that real quick because I kind of fat-fingered something there. So what I'm going to do is come to x equals 4, and I'm going to just go ahead and seem to be having problems with this pen tool. So I'm going to just undo that again. All right, so let's try it again. 1, 2, 3, 4. There we go. That's a little bit better. All right. So there it is. It's a line that goes right through that vertex. Okay. All right. So the way you find the axis of symmetry is first you find the vertex, and then the axis of symmetry will always just be x equals whatever the x value is of your vertex. Okay. And it's a vertical line, and you just like sketch it in if you're asked to sketch it in. Okay, so That's it. Pretty short and simple. Shouldn't be too complicated. If you have any questions, of course, in class, just do speak up and let me know. All right, now, finally, y-intercept. Well, y-intercept for any curve, whether it's a line, a parabola, something cubic, it's always where x equals 0. Okay, so the way we find our y-intercept is we plug in 0 into the equation that defines our curve. In this case, it's that 1/2 x squared minus 4x minus 3. So let's just go ahead and do that, and we'll find out that, oops, we're going to find out that, oops, I need to, here's this pen again. We'll find out that y equals, and it's still using that dash feature. All right, so let me just see if I can retrace that. Y equals, okay, so it's 1/2 times, 0 squared, okay, minus 4 times 0 minus 3. Now, if you're really astute and paying attention, you would notice that over here, both of these terms have an x in them. And whenever x is 0, it just makes those terms 0. So this whole thing would just reduce down to y equals minus 3 would give us our y-intercept, okay? So, so let's just do it longhand, though. So 1/2 times 0 is 0, minus 4 times 0 is 0, minus 3, okay? Well, that all just equals minus 3, okay? So y equals minus 3 when x equals 0. So I could come over here now to 0 minus 3 and plot a point. Okay, so there's my y-intercept at 0 minus 3, because a y-intercept is a coordinate pair, so we would also write it like this, 0 minus 3. All right. So, so I've showed you how to find the vertex, how to find the axis of symmetry, and how to find the y-intercept. There's one more thing, though, that's kind of important. So this thing called an axis of symmetry goes right down the middle of the parabola. All parabolas are symmetric, okay? So they look the same on one side as the other. So what this means is that if I have a point, any point that's not the vertex, okay, it can't be the vertex because the vertex is right on the axis of symmetry, so that wouldn't work. But if I could take a point like the y-intercept, I can count off how far it is from the axis of symmetry. In this case, it's 1, 2, 3, 4 units, okay? Well, that means also that once I get to that axis of symmetry, I can continue on for 4 more units and go 1, 2, 3, 4. And now I can put another point right there. That's part of the curve because it's symmetric. Okay? So that's part of what is really powerful about this axis of symmetry concept. All right. Now, finally, and I'm not going to ask you to do this, but you should be able to see it and know how this all works, okay? I'm going to use the red pen, okay? And I'm going to come over here and just select the pen again. Okay, and right down here where my vertex is, I'm going to just kind of like approximate like a turning of a curve, okay? Because it goes through our vertex and then it goes on forever, and then it comes down from here, right about to there, okay? And then I'll just like extend that up, all right? So now I'm just kind of like sketching in, the rest of the parabola. Now I'm doing it freehand. It doesn't work as well as when you use graphing software, but yeah, that's how you build out your parabola. I'm not going to ask you to do that, but I am going to ask you to make sure that you know how to find the vertex, the axis of symmetry, and the y-intercept, okay? Because that's what you're going to be tested on. All right. Hope you found this video to be useful, and you can watch it over and over again, taking down into your notes how to do all these things, because again, that's what you're going to be tested on. All right. Have a good one, everyone.